Hey everyone, and welcome. This is section 3.3, vectors in a plane. Now it's kind of dealing some with law of sines, some with law of cosines. We are still dealing with triangles, but we're going to be dealing with vectors because they have components to make triangles, but they're also really, really important in physics. All right, so what is a vector? You might have seen them before in physics or other classes you might have seen them, but here's a good example of why we use vectors. Let's say that there is a buried treasure west of school, and it's directly west of school. So that means you could go from here, from school, and you could go west. You could just walk that way, and it would be somewhere in here. Let's say you don't find it. All right, so now maybe you have to expand your search a little bit. So you start here at school, and now you're going to go west a little bit. You got to cross 72, maybe cross 72 again. Okay, so you still don't find it. What happens if you now go west a little bit further, over 39, past Davis Junction, all the way out here? Lanark maybe has it. But what happens if that doesn't? You could start here, and you could go across the country all the way this way. So you probably need a lot more information if you want to know where this buried treasure is. You need to know what direction to go and how far. And those two things are what vectors are all about. They tell you what direction and how far to go. All right, so let's take a look at some vocabulary and some other stuff. And right here's where I need to be. Okay, so vectors in a plane. Vectors are directed line segments. So, for example, a directed line segment means you have a line segment. It's got an arrow at the end, which means P is my terminal point. P is not my terminal point. P is my initial point. See? There you go. There's a lot of vocabulary, a lot of stuff you need to know. P is my initial point, and Q is my terminal point. All right, so you know where you start and where you end. If you're just talking about in geometry, we have a line segment, and it doesn't really help. It's like a ray. It starts here as my initial point, goes to here as my terminal point. It's not an endpoint now. Like in geometry, it's called an endpoint. Now in vectors, it's called an initial point and a terminal point. All right, so that's what a directed line segment. It's like a ray where we have, it has a direction, starts at P, goes to Q. All right, and it's written as P, Q, and it's got that. Now, can you see that? It does not have an arrow like a ray. It only has the one to say that this is a vector and not a ray. All right, so it's just got the one little arm, not both arms that complete the arrow. Now, it does on the picture, see here, but it does not on the notation. So the notation is P, Q, and we know that P is my initial and Q is the terminal. All right, so that's how we're going to write directed line segments. We're going to write it as the capital letters and then one part of the arrow. All right, so that's the first part. The next thing is magnitude. Now, magnitude is a lot like distance. All right, how far is it from the terminal point to the end point? All right, so what is the magnitude? That's what we're going to be using now, and it's called distance. And here's how you write magnitude. If I want to know what is the magnitude, aka what is the distance between P and Q, what I do is I write PQ, and we got double lines. Kind of like absolute value, they're a little bit bigger than PQ, so it doesn't look like a 1, 1, PQ, 1, 1, or an II, PQ, II, or any combination of those letters. All right, it's going to be like a double absolute value sign. All right, and when you see that, you think magnitude of PQ. All right, so there you go. That's magnitude, and now we're going to talk about vectors in a plane. A vector is a directed line segment. It is the exact same thing. A vector has a magnitude and a direction. All right, so we can call this thing that we have up here PQ. So we could say ray PQ is the same as vector P. All right, and I'll be right back. Hold on one second. All right, everyone, I'm back. And so we're talking about PQ as vector v. Now, vector v, it's bold. Notice how all these vectors are u, v, and w. They're all bold, so make sure you write them as bold. That way someone who is looking at your paper would know that it's bold and it is a vector. So you can write pq vector v, or you can just write it as vector v. So you have to actually write it the words vector. If I could do a bold lowercase letter, I know I'm talking about a vector. All right, so now we're going to be looking at component form of vectors. So if I'm saying P is the point P1, P2, and Q is the point Q1, Q2, what I want to do is if I want to write PQ as a directed line segment, I can also write it in component form. So what we have to do is I want to find, it's kind of like finding the difference in the x's different in the y's, difference in the y's. Same idea. So what we're going to do is we're going to do Q1 minus P1, right? I'm going to find the difference in the x's, so that's from Q1 to P1. So that's going to be that part. And then the other part is going to be Q2 minus P2, right? P2 is y, Q2 is y. So it's just like finding the differences. Still by a comma, like you were to make a point, but now instead of putting parentheses, you're going to put pointy parentheses. All right, and that's the component form of the vector with initial point P and terminal point Q. So it's going to be not parentheses, but like parentheses separated by a comma, like you would a point. The only difference is instead of having curly parentheses, you got them pointy. All right, so there we go. If we want to find the magnitude of this vector, let's call it V. Magnitude of V. Let's call this vector V. I've got dark colored V, so that way I know it's bold. That's just going to be the square root of how far is it from P to Q. So it's going to be Q1 minus P1 parentheses squared plus Q2 minus P2 parentheses squared, and keep my square root all the way through. So the magnitude V is going to be that. If the magnitude, remember this means magnitude, double letters. Nice job over there. Magnitude, double absolute value sign, capital, I'm sorry, lowercase, bold, V equals 1, then that is the unit vector, which means it only has a magnitude of 1. Everything on the unit circle, for example, is a vector of magnitude 1 because it always goes out to a total of 1 because it's the radius of the circle is 1. Right, so that'd be a time where a unit vector is 1. If the unit vector magnitude I'm sorry, not the unit vector. If the magnitude happens to equal 0, what does that tell you about how long the vector is? Well, I'm starting at point P, I'm ending at point Q, and it is the exact same point. So that means that we don't really have a vector at all. It's just you start and end at the same point. All right, there you go. So now let's go over to solving some of these problems. All right, so we go back to here, and let's do one of these. So, oh, you can't really see what's going on because I'm in the way. There we go. We'll just move me. Here I am. And it says show u equals v. So what we want to do is we want to say we could use the distance formula to figure out what is the distance from u from initial to final, and then do the same thing for v. All right, so what I'm actually going to do here is I'm going to figure out how far is it up and over as if I were to find the slope. So going up is 1, 2, 3, 4, and then going over in the x direction is, let's go to there, we have 1, there we go, 1, 2, 3, 4, 5, 6. So I'm going up 4, and I'm going over 6. Now they're both a positive. So what should happen if I have this correct is it should happen the exact same thing for v. So if I go up 1, 2, 3, 4, that's good. And then I go over 1, 2, 3, 4, 5, 6. Now my arrows aren't exactly right, but you know what I'm talking about. So it's going over 6, and it's going up 4. All right, so we have gone up 4, right 6 for both of them. So if this is the same as this, then my hypotenuses are going to be the same as well. All right, so the slope is the same, right, for this ray. So if one was going up 4 or up 8, right 12, it's not the same vector anymore because now I've gone up too many. So it's not like a slope where you can just reduce the fraction. It's got to be exactly the same. You can always use the distance formula as well if you need to. Either way is okay. All right. So here is another one. I'm kind of in the way, but you can probably get this to be all right. Okay, now you can see it. Find the component form and magnitude of the vector v that is initial point 4, -7 and terminal point 1, -1, 5. So I'm starting from my initial point at 4, -7, which is down here, and I'm going to travel up to this point here. All right. So I want component form. If you can remember, component form is going to be something right here. So I want to take the terminal point minus the initial, and the terminal point minus initial for both the x and y points. All right. We will get to that one here in just 1 second. All right. There it is. All right, we are back. So now we have to find the initial point 4, -7 and terminal point -1, 5. So what we want to try and do here is we are going to try to figure out, first of all, what is the component form. So that means we're going to do terminal point, there we go, terminal point minus initial point. All right, so we have terminal point is the -1. So I'm going to put the, oh, you can't see it. There we go. Let's do it down here. We got the terminal point. We're going to have those right here. And then what we are going to do is we're going to do -1 minus 4, right? The x's minus the x's, comma, 5 minus -7. And I'm going to put those in there. Oh, and you can see it now. There we go. Okay. So then I will have -1 minus 4 is going to be -5, comma, 5 minus -7 is going to be 12. All right, so there it is in component form. So it says find the component form and magnitude. So we found the component form. Now we have to find the magnitude. Now we didn't really find the magnitude last time because we just compared them. So what we're going to do is now we're going to find the component form of our 2 points. So it's going to be the square root. Hold on there, little girl. It's going to be -5 squared plus 12 squared. All right, -5 squared is 25, 12 squared is 144. Take the square root, and the square root of 25 plus 144 is 169. Take the square root, and it should equal 13. So the magnitude of PQ equals 13. If I say the point, if I said the vector was V, I could rewrite that as the magnitude of bold lowercase v equals 13. There you go. All right, so before everyone else starts to break down crying, let's do this assignment. Here's what I expect you to get done, and I can just make this full screen so it's a little bit easier to see. Find the component form and magnitude of the vector u that has initial point -3, 8, and the terminal point 6, 5. All right, and good luck.